Alright, 11.6 deals with segment relationships inside circles. We're going to start with the chord product theorem. And that just says if you have two chords that intersect, then the pieces like CE and DE, then you have this other piece BE and AE. Those four pieces, you can actually multiply them together and get an equation. They're going to be equal. So AE times EB is equal to CE times ED. So let's look at this and put some numbers in here together. I know from this theorem, I got two chords, GH and FE. So that just says simply that 14 times X is equal to 7 times 10. So 14X is equal to 70. Divide 70 by 14, and we get that X is 5. Okay. It also says, and the length of each chord, so then we'll go back and we'll say, so GH is equal to 14 plus 5, which is 19. And FE is equal to 7 plus 10, which is 17. All right. Same thing with number 2. I'll let you do that one. Since it's the same thing, you're going to do 6 times 5 is equal to 8 times X. Alright, and then we'll talk about secants now. A secant segment is a segment of a secant with at least one endpoint on the circle. An external secant is a secant segment that lies in the exterior of the circle with one point on the circle. So here's some examples. PM, NM, KM, and JM are secant segments of circle Q. NM and segment JM are external secants. Okay? So next theorem that we're talking about is a secant-secant. And it works very much like the chord product theorem, where we take AE, or we're taking two segments and we multiply them together. This one's a little different because this one is AE. It's the whole segment times the outside part, BE, is equal to CE, the distance from C to E, which is, again, the whole segment, times the external secant, which is BDE. So let's look at an example of that. So for 3, I would have 39, because I would add 30 plus 9 times 9 is equal to 13 times Z plus 13. Because I have to use the whole entire length. If JH is Z and HG is 13, then J to G is going to be Z plus 13. All right. So then I'm going to have to distribute 39 times 9 first is 351 is equal to 13Z plus 169. So I need to subtract 169 from 351. I get 182 is equal to 13Z. Divide by 13. We get that Z is equal to 14. All right, so there's one part of my question. It says find the value of Z and the length of each secant segment. So JH is going to be 14. JG would be 14 plus 13, which is 27. And then the rest of them are done for you. KG is 9. We can say KL would be 30. And then GL would be 39. So those would be all the different secants. All right, number 4, I'm going to leave that one for you because, again, that's basically the exact same type of problem as example 3. It would be 8 times x plus 8 is equal to 7 times 16. Next theorem we're going to talk about is a secant tangent product theorem. This one, again, same basic idea, except we have to throw in a little exponent here. AC, which is the entire secant, times the external secant, BC, is equal actually to the tangent squared. All right, so Again, let's look at an example to kind of make this a little easier for you to understand. My entire secant has a length of 5 plus 15, which is 20, times the external secant of 5 is equal to x squared. All right, so x squared is going to be equal to 100. If I take the square root of 100, we get that this would be, technically it would be a positive plus or minus 10. But since we're dealing with length, I'm just going to have to use the positive value of x being 10. Alright, so let's try this again. I'm going to have example 6. This is going to be 7 times y plus 7 is equal to 10 squared. So 7y plus 49 is equal to 100. 7y is equal to 51. And then if we take 51 and we divide by 7, we get y is equal to 51 over 7. That does not simplify, so that would be my answer. In the event that I were to ask you to round, which I didn't, but just in case I did, you would round to, this would be about 7.29. Okay, but I didn't say to round, so I want exact answers, which would be this 51 over 7.